iko maana venye zinakaa mutation.
Makdi?
Yes, sir.
Kindly unmute our water.
Okay, I'm doing it. I think I've muted everyone, so you can.
They are very noisy.
What do you think coming? You say that.
Unaenda tu kwa unaona shilingi ni mbili. Hii ni ya YouTube. Hii yako ni ya YouTube. Hii ya chini.
Umeendaje kwa umeendaje? Umefinya, umebonyeza.
Unarudi tu unakuja.
Community passport.
89.
The 9.
Okay, now we can move. Makdi, kindly just mute while on Asungwa. So last time we had talked about computer system. Today we had talked about the keyboards. Talked about the Mikri, the Okri. Okay, so So today, we are talking about processing devices. And that is very important because we had already looked at the point of sale, the scanners, the digitizers. Now we start with the processing devices. And here, the procedure that transforms raw data into useful information is called processing. So to transform this information, the computer uses two components, the processor and the memory. So the processor is like the brain of the computer. It organizes and carries out instructions that come from either the user or the software. In a personal computer, the processor is usually consists of one or more specialized chips called the microprocessor. So these microprocessors are also called the central processing unit, CPU. So the CPU receives data, and you can see the diagram of the CPU very clearly shown there. We have the input devices, we have the output devices, then we have the central processing unit, which entails the memory unit, the ALU, which is the arithmetic logic unit, and the control unit. And you can see it there very clearly. So we are talking about that central processing unit. What are the functions of the central processing unit? To perform all the processing, including computations, control the sequence of operation, give commands to all parts of the computer system, controls the use of the main storage to store data and instruction. So the CPU consists of three components. As we've said, you have the control unit, the ALU, and the primary storage unit. Each unit has a particular function. So we have the control unit. As we start this discussion, you may say that control unit is the major part of the CPU. The control unit essentially governs all the computer activities, monitors the execution of programs. It coordinates and controls the computer system, much as the brain directs the body. So the control unit executes program instructions to be fetched from the main memory via the MDR. This is a register, and placed into the instruction register, which is IR. So when main memory storage receives appropriate signal from the control unit, it transfers the instruction whose address is specified in the memory address register into the processor's MDR via the data bus. So the control unit interprets the instruction in the instruction register and causes the instruction to be executed by sending command signals to the appropriate hardware device. E.g., it might cause main storage to transfer data in the MDR, or it might cause the ALU to perform some operations on data registers. So the cycle is then repeated while the next instruction is being fetched. And the next part we're going to look at is what we call the arithmetic logic unit. So the next part of the CPU that is greatly of importance, especially during processing, is the ALU, and has two main functions. It is responsible for performing all arithmetic, add, subtract, multiply, divide. It performs all logic operations, testing whether two items match. So data items to be processed are taken from the main storage as directed by the control unit and passed via the MDR into the data register in the ALU where they are stored. This step is referred to as loading data into data register from the main storage. It should be noted that at this point, the location address of the data will have specified in the instruction register from where they will have transformed to the memory address register prior to loading the data. So the ALU then performs the required operations on the data as directed by the control unit The ALU leaves the results in the data register. While the ALU is carrying out an operation, it may take use of other registers as its own, such as operand and results register. For example, it may build up a result in the results register before sending the complete results to a designated data register. So the results are taken from the data register and placed in the main memory, again under the direction of the control unit. This step is referred to as storing data. So this is what also happens because your phone, a smartphone also has, the ALU has the control unit. It also behaves the same way as like a computer. Then we have the primary storage unit. One might ask themselves, so where does we introduce computer go to? Because people always ask such questions. It will be interesting to learn that the computer has storage unit that stores all programs and data. So memory of the computer, memory or storage capacity is one of the important components of a computer. Any storage unit of a computer system is classified on the basis of the following criteria. So one of the criteria is access time. This is the time required to locate and retrieve data from the storage unit in response to program instructions. The storage capacity, it's the amount of data that can be stored in the storage unit, cost per bit of storage. Unit of memory, the computer stores a character in the storage cells with a binary 0 and 1 mechanism. Thus, the basic unit of memory is a bit. Bit is binary digit 0 or 1 to store a character. A computer requires 8 bits or about 1 byte. This is called the word length of the storage unit. Hence, the storage capacity of the computer is measured in the number of words it can store and is expressed in terms of bytes. The different units are measured. So 8 bits. So if you have 8 bits, then you call it, you have 1 byte. If you have 1024 bytes, that one is equivalent to 1 kilobyte. If you have 1024 kilobytes, that is equivalent to 1 megabyte. And if you have 1024 megabytes, that is equivalent to 1 megabyte. So the question is, if I have a million kilobytes, what size of flash disk do I need to buy? Can we see the answers on the chat finally? If I have a million kilobytes, can you type on the chat? If I have a million kilobytes, based on this conversion, how many GB of data how many GB of flash disk do I buy? If I have a million kilobytes of data, what's the conversion? Can you convert and tell me? Show me. If I have 1 million, do the calculation. It's mathematical. I have 1 million kilobytes. Can you type the formula the way you have gotten? If I have 1 million, if I have 1 million, I have 1 million. I have 1 million. Do the calculations, man. Me nataka nione calculations. So if you are doing this fast, you have to divide one. Okay. these are 1 million kilobytes. So you divide them into megabytes, then you convert them into gigabytes. So I said, how many gigabytes are they? So if first convert the kilobytes, these are million kilobytes, convert the a million kilobytes, convert the million kilobytes into megabytes by dividing by 2024, then divide the megabytes by another 1024. It gives you what? The answer is what? Where are you getting 8? So the first thing, you divide the million by 1024, which gives you megabytes. Then again, you divide by 1024 to give you GB. So these are the results I'm seeing here, some 10 GB. I don't know where you're getting them. The people who are close to 0.9, they are okay. And okay, that one, you mean you can buy a flash disk of 1 GB. That one, it means that. But now you need to know the conversion. So that's what we are saying. And that's the communication here.
Maybe as we continue, those who are on YouTube who are saying that the screen is not clear, kindly put your screen into full. Click on that button where you can make the display to be in full screen. Then change your display from portrait into landscape. For those who are YouTube who are saying that the screen is not clear, put the YouTube into full screen, then change your orientation into landscape. Don't put it in portrait, put it in landscape, and everything will be clear.
But if I do that, can it improve? Have I improved it?
Just
have I improved it on the YouTube?
Yes, I think if students can change, they can put the display into full screen and change into landscape to be better. Yeah, I think that one is okay. That's okay.
Yeah, so what I'm saying is make sure that you can convert kilobytes. Now, you can also convert 1024 gigabytes. That's what is missing there. 1024 gigabytes is equals to 1 terabyte. So, terabyte. So, you can also get terabyte. So, the storage capacity of the CPU is called the primary storage unit. Over the years, the storage unit has been called main storage, internal storage, primary storage, or memory. Primary storage provides the capacity to store software in the form of operation systems, application programs, and utility routines. In addition, the data input for processing is stored in the memory. As the result of processing unit, they are output either to back storage or to an output device such as a printer or VDU. So next we are going to discuss the types of storage. We have different types of storage. We have the core storage and we have what we call the semiconductor memory storage. So we go back a little bit to understand the history of core storage. During the 15 years between 1960 and 1975, the dominant computer design used tiny rings or cores of magnetizable material in the primary storage section. But currently, flowing in one direction produce a 0-bit state. Since the core permanently retained its magnetic state in the absence of current, it has a non-volatile storage media. So core storage was popular for 15 years because it was safe, durable, and reliably fast. But the new storage devices that appeared in the 1970s offered even faster performance at a low cost And so the popularity of the cores quickly faded. So semiconductor memory. Now this one is different. Virtually all computers made towards use of semiconductor elements in their primary storage section. It produced from silicon chips and is based on two types of technologies, i.e. the faster and more expensive, that was the bipolar semiconductor chips, and the slower and less expensive metal oxide semiconductor chips. There are two types of semiconductor memory, which you really need to know. We have what we call the random access memory, RAM. When you're going to buy any phone, you always ask yourself, RAM ni ngapi? So this RAM is very important. This is the first type of semiconductor memory. These are referred to as random access memory chips because any of the locations on the chip can be randomly selected and used to directly store and retrieve data and instruction. This type of memory can be both read to retrieve information and written into information. Raw chips may be classified as dynamic or static. The storage cell circuit dynamic RAM chips contain transistors that act in much the same way as a mechanical on-off switch, capacitors that is capable of storing an electric charge. Depending on the switch action of the transistor, the capacitor either contains no charge or does hold a charge. Since the charge on the capacitor tends to leak off, provision is meant to periodically regenerate or refresh the storage charge. So a dynamic RAM thus holds volatile storage. That is the data stored are lost in the event of power failure. Then we have static RAMs. The RAM chips are also volatile storage devices, but as they are supplied with power, they require no special regenerator circuits to retain the stored data. In real sense, the contents of the static RAM remains stable forever as long as power is available. So now, because we cannot go into groups, but we are just saying, we are saying that in what in groups can you discuss on the chat? List the difference between static and dynamic RAM. Can you list on the chart the difference between? On your chart, can you list this? List the difference between static and dynamic RAM. Can you list the difference on the chart? On the chart, can you list the difference between dynamic and static RAM? On the chart, can you list the difference? On the chart, can you list the difference between dynamic and static? keep them coming. Keep them coming. Can see your. Yeah, so good. I can see most of you are trying and you're getting it right. So we are moving next. So keep the discussion going. Keep the discussion going on the chat. Keep the discussion going. So let's move. We are now moving next to what we call a RAM, read-only memory. A RAM is a read-only memory that can only be produced by a manufacturer. The contents of a ROM are physically fixed and cannot be accessed to alter them as can be done with the RAM. So microprograms, control instructions that can cause the machine to perform certain operations are usually stored in the ROM. The contents of the ROM are not destroyed when the computer is switched off, as ROM is non-volatile because its contents have been burned in during manufacture. ROM also stores the operating system. So programmable read-only memory, that's the PROM. These are violations of ROM, variations, not violations, sorry, variations of ROM. So the PROM stands for programmable read-only memory, whereas the ordinary read-only memory is pre-programmed at the factory. The PROM can be programmed by the user. So normally when you have bought your phone and you get the word Android, you get the word Nokia, that one, what is the operations that is working on that is actually what you call the pre-programmed. Now it is programmed at the factory level. So a special device. So we have the program. This one can be programmed by the user. But normally when you buy any computer, if it's a Dell, you will get, when you open, the first thing you see that message, actually that's part of the ROM. That one comes from the ROM and it's programmed at the factory of the manufacturer of the device. If it is Huawei, you will see Huawei. So Huawei, that one will stand again. That one is done in the ROM. So it's very important for you to know that it happens. Even if you buy a TV and it's Samsung, you will see that from the ROM, you will see the word, you will see the word that you're talking about in that particular. So the question I may ask is, what is the main disadvantage of the PROM? Because the PROM, this one, what could be the main disadvantage of the PROM? We have talked about the ROM. We have talked about the PROM that can be made by the user. A special device is required for inputting the bit pattern into a PROM chip. This is called a PROM programmer. So what's the main disadvantage of using PROM? What could be the main disadvantage? Can you put it on the chat? Yeah, keep the I like one point here. Somebody has said that if the programmer does not know how to program, then it will be worthless for him to use the prompt. That is very right. I think you got it very well. So let's move on. We have the erasable programmable read-only memory. This is a further variation of the ROM, which stands for erasable programmable read-only memory. When data is recorded on this type of memory, it is in effect the same as ordinary memory ROM in its behavior, but if the user requires to change the contents of the chip, an ultraviolet light is used to revert all the cells to ones. New data or programs can then be written on the chip. So what is the disadvantages of EEPROM? Now, can you type the disadvantages? What are the advantages of EEPROM? EEPROM is erasable programmable read-only memory. What could be the disadvantage? I can see you're getting it. And even the idea that it's also using ultraviolet light, it also becomes tricky even for the programmers. So it's good that you're getting what I want. So we go to what we call EEPROM, the electrically erasable read-only memory. EEPROM, the electrically erasable programmable read-only memory, is a user modifiable read-only memory that can be erased and reprogrammed repeatedly through the application of higher than normal electrical voltage. So unlike the EEPROM chips, the EEPROMs do not need to be removed from the computer to be modified. However, an EEPROM chip has to be erased and reprogrammed in its entirety, not selectively. It also has a limited life that is the number of times it can be reprogrammed is limited to tens or hundreds of thousands of times. So in an EEPROM that is frequently reprogrammed while the computer is in use, the life of the EEPROM can be an important device, an important design consideration. Then we have what we call the flash memory. The flash memory is a type of non-volatile memory that erases data in units called blocks. A block stores on a flash memory chip must be erased before data can be written or programmed to the microchip. So flash memory retains data for an extended period of time, whether a flash-equipped device is powered on or off. So we have what we call the flash EEPROM. Flash electrically erasable programmable read-only memory is what we're talking about now. Now, I remember I was talking about the memory registers, and now here is where I want to draw the line and get you to know what registers are. So to understand how the above components, that is the control unit and ALU of the CPU works first, we need to first understand the registers, which is a special purpose temporary storage location within the processor or any other devices within the computer system. They are quite separate from the location in main storage, although they can be similar in structure. Types of registers and their functions. Registers may be classified into two main groups. So we have registers out of the processor and we have registers in the processor. So the registers out of the processor, I remember you talked about MDR, so I knew that I'm going to talk about them, so I didn't want to bother. But now here we can talk about the MDR. Registers out of the processor, you have the memory data register. All data and instruction pass in and out of the processor through this register. Memory buffer register. All data and instruction pass in and out of memory through this register, the MDR register. Then we have the MAR register. Prior to each transfer between the processors, the memory address register between the memory. So the MDR is what we have talked about here, which is the memory data register. Remember that. So prior to each transfer between the processors, main data register, memory data register, and the main storage is the memory address register. No, inaitwanga memory buffer is it here? MDR is it? So let's start. So we've said prior to each transfer between the memory data register and the main storage memory buffer register, the exact destination of the data in the main storage must be specified. This is done by loading the appropriate location address in the main address register. Main memory receives this address information through the address bus. It also receives control signals from the processor via the control bus, which is able to decode into commands for it to save or retrieve data. Then we have the data buffer register. The data buffer register, another important register, is the DBR, which is the data buffer register, on which input and output connected to the processor via a bus also have these registers, which serve as a similar purpose to the memory buffer register. So register in the processor. You know, you have registers in the processor. Those were outside. Those are inside. There we have the instruction register. This is the first register you encounter in the processor when the next executable instruction is taken from memory via the memory data register and placed. Once in the instruction register, the instructions can be rapidly decoded and executed. Note that the instruction register, also sometimes called the current It's also sometimes called the current instruction register. Then we have the data register. This register is within the ALU in which data to be processed. It's placed from the main memory via the memory data register. The required arithmetic or logic operation is then rapidly performed. So the ALU will provide the results in one data register from which it can be taken and stored in main memory storage. Then we have the status register. This is used by the control unit as a means of detecting conditions which have occurred, such as the ALU detecting the arithmetic error of dividing by 0 primary components of the processor, which now may be considered in detail. So kindly on your own list the types of processors, registers, and their state and their functions. So you can do that because I've talked about them. So we go to next what we call bubble memory. From the processor, we look at different types of memory called the bubble memory. Bubbles may be described as a cylindrical magnets, which are formed from magnetic regions called the domains after the application of a critical bias value magnetic field. The bubbles are created on memory chips of thumbnail size with capacities of typically 64 and 254. The ICDL and DNX 2000 digital PABX systems use bubble memory. So it seems that this type of memory is likely to be used widely in the future. So it's mostly the bubble. Then we have the holographic memory. This is a ROM, optical memory system, whereby a pattern is recorded on a photosensitive plate by mixing laser light from reference beam and laser light scattered from the object bearing the information to be recorded. The data in the hologram is effectively smeared over the whole of the plate. A degree of redundancy is built into the system so that the dust and scratches and the emulsion have little effect on the recorded information. Data in the reconstructed image is arranged as an array of dots, one dot for each bit. Information may be read out by directing a laser beam on the hologram so that the reconstructed image falls to a photodiode array on a silicon chip. At present, the main limitation is that information on the graphic store is generally fixed and is presently of value for storing large amounts of fixed information, such as machine instructions. So we have what we call the cache. The cache is a high-speed memory capable of keeping up with the CPU. It acts as a buffer between the CPU and the slower main memory. As the CPU is not delayed by the memory access, the overall speed of processing is increased. Segments of program and data are transferred from disk backing storage into the cache buffer by the operating system. This type of memory is mainly applicable to the larger computer. Let us now look at the different types of buses, and here a bus is a channel or a pathway from the processor to another, including transferring data from internal memory to the arithmetic unit. Buses also provide the channels for one, transmitting the signals related to the address of the data to be operated on, the input and output of and from specific peripheral devices, the transmission of signals for controlling all processing activities. So after knowing these factors above, it's important for us to discuss each bus on its own and what it does. So we have what we call the address bus. This type of bus is used in processing, is the address bus, which is used to send address details between the memories and address register. the address of the data to be operated on the operand is stored in the address register. So the number of channels on an address register, the number of channels on the address register, the larger the address register, the possible internal memory capacity, because the larger the number of addresses that can be generated, the better that particular device is. So the value of binary digit doubles each time the one moves in a higher order position, i.e. to the left. This follows from the binary progression to n. Then we have the database. These are bidirectional bus that carries information and data to and from the microprocessor. The data bus determines the width of the microprocessor, hence the denotation as 8-bit, 16-bit, 32-bit. They are typically created by the microprocessor registers. So the control bus, these are unidirectional buses that carry command signals from the microprocessors, and sometimes the signals are to the microprocessor itself. The direction of the transfer on the data bus is indicated by the control signals from the control base. So the peripheral devices, these facilitate the connection of the devices. So you can be able to confidently say what's a computer bus, list any 3 types of buses and explain their function. So this is something that just a recap. So after dealing mainly with the devices that concentrate on converting data into information for ease of use, let us now move further to a new section that will enable the user to communicate with the computer by giving them results called the output devices. So we are going to look at what we call the output devices. In this section, we discuss various devices that can be used to give feedback to the user. The results of any form data processing are output. Of any form data processing are output. That's what we call an output. So an output is device is a peripheral which shows the computer output either in soft or hard copy. The output can be used immediately or stored for a later use. So output can take many forms. Output might be human sensible, which means that it can be recognized and understood by the human beings. It requires special machines for it to be accessed by the people, e.g. computer output on the microfilm or microfiche, where microfilm or microfiche readers are used to access the stored data. An output device should also be computer sensible with the output data or information stored for later processing by another computer. So quickly, can you give me the output device? Give me what are the output devices? Can you give us the output devices, on the chart? Give us the output devices, list the output devices, A scanner is an input device. It cannot be an output device. Check your will. A touch screen is an input device and also an output. The monitor, the speakers, the printers. Can you give me all of them? Kindly give me, keep them coming. Keep them coming. Keep them coming. Just keep them coming. A mouse is an input. Keyboard is an input device. Kindly, those who are confusing. I can see also somebody saying a projector. But I've seen somebody saying a keyboard. Actually, a keyboard is an input device. Check your notes well. So let me just correct that. Yeah, headphones can get you. Yeah, that's okay. So thank you. I think I can see from your screen. I think you've been seeing what people post, but things like a mouse and a keyboard, we say those are input devices. So when you say they are not output, can you go back to the notes kindly and check? So the human sensible output consists of the printed output and the visual display unit. So it's an important output device. Now we are going to look at the printer. The printers this is an important output device beside the monitor. Generally, the printers fall into two categories. Printers can be classified by whether they print a character, a line, or a page at a time. So we have printers that print characters at a time. So they are called character printers. Printers print serially, one character at a time, much like a typewriter. As a result, speed are very slow, from 10 to 150 characters per second. They are relatively cheap and are commonly found in business systems. When a keyboard device has a character printer attached, it is called a teletype or a typewriter. Teletypewriter. So the keyboard acts as the input media, and the printer as the output device. So there's no day a keyboard will be an output device. It is an input device. Kindly, those who are typing in the chat, kindly correct that notion. Line printers are much faster devices which print a line at a time. Some are capable of printing up to 3,000 lines per minute. They are accordingly more expensive. Then we have page printers. They print a whole page at a time. They're expensive and are intended to deal with very large volumes of printed computer outputs in large organization. Then printers can be classified according to their technology. So we have what we call the impact and non-impact printers. So the impact printers, this require the heating of inked ribbon against paper, just like ordinary typewriter. Impact printers are noisy in operation. So when you hear a printer that knocks the paper and you hear a lot of noise, that's what we call the impact printers. But we also have what we call non-impact printers, such as the laser printers, use different technology, such as ink spray, heat, xerography, or laser to form printed copy. Characters are not formed by mechanical impact. So what's the difference? Kindly on the chart, differentiate between impact and non-impact. I've already said. Can you differentiate that very fast on your chart? The difference between impact and non-impact printers. Kindly on your chart very fast. Difference between impact and non-impact printers. Kindly do it very fast on your chart. What's the difference? I've just talked about the difference. Good. I think we have talked and I can see people are getting it, so we are not going to waste time there, but I can see we are moving. Thank you very much. So we move on to the next thing, which is, so we have also, printers can be classified by the quality of print they produce as below. So we have dot matrix printer. These are impact printer, character printers that produce character prints in terms of dots. They print characters as in array of points or dots. The quality of print varies according to the number of dots that produce up a character. However, it is a slower printer. So we have the dot matrix printer. We have what we call the daisy wheel. It is the oldest kind of printer, which is an impact printer. Works like a typewriter, where a piece of metal or plastic with a raised letter strikes an inked ribbon against a sheet of paper, leaving an image of the letter on the paper. Then we have the neat letter quality. A printer offers neat letter quality is one that provides a quality of print that is near but not quite as good as a typed letter. Additionally, printers can be classified in terms of speed. The basic types of printers will now be explained in detail. So we have the impact character printers. There are two basic types of impact printers. We have the dot matrix and moving print head, ball or wheel. So the dot matrix, as we have said at the top, prints patterns of dots in the shape of a desired character. Speed of up to 165 characters per second are possible, but the print quality may be low. However, some dot matrix print have a neat letter quality print. So this is what we call a dot matrix, and sometimes you have seen it. Look at that shape. That's what we call a dot matrix. Then we have the ball. A ball printer uses a rotating or pivoting ball as a print head. The printing characters are on the surface of the ball, which strikes a ribbon to transfer the characters onto the paper. We have such like the IBM Golf Ball electric typewriter. So the wheel or the daisy wheel printer uses a wheel as a printing head, with the characters forming a band around the circumference of the print wheel. To print a character, the wheel is rotated and a hammer strikes the back side of the spoke and presses it against the paper. So sometimes you go and you see a chapa, that one now could be a daisy wheel. Then we have the daisy wheel. No, that could be a wheel printer. And then we have the daisy wheel. Some balls and some wheel printers can print left to right on the next, thus increasing the effective print speed. They print at relatively slow speeds, typically 10 to 50 CPS, copies per second, but produce good quality print, full letter quality characters. So a dot matrix printer and a graph plotter can both be used by a shop that designs and sells fitted kitchens to produce the kitchen plans on different plan sizes and using color. So I'll explain which one will be better in this situation, but a graph plotter will be better because it's meant to do that. That's what I know. So which one will be better? Then we have the impact character printers. These are printers that use other means to create an image. Inkjet printers, for example, use tiny nozzles to spray droplets of ink onto the page, while laser printers work like photocopiers, using heat to bond microscopic particles of dry toner to specific parts of the page. These are various types of the non-impact printer. So we have the thermal printer. So it creates print images on special heat-sensitive paper by using heated wires in the print head, and they operate at a speed of 160 characters per second. That's one. Then we have the inkjet printer. These printers use the concept of spraying ink on the paper, fires ink onto the paper by using an electrostatic field. No special paper is needed and the print quality can be good, but it is not possible to produce multiple copies and they can be unreliable. We have line printers. There are mainly three types. We have impact line printer. One is the impact line printer. These are two main types of impact line printers. Print characters are mounted on moving chain or belt and engraved on the face of a rotating drum. Typically, line printers speed range from 200 to 300 lines per minute. So multiple copies can easily be produced and characters are of letter quality. The main non-impact line printer is the electrostatic printer. This places electrostatic charges in the shape of the required characters on a special sensitive paper. They are not common in business operations. We have also the magnetic printer. A magnetic printer operates much like the electrostatic printer, except that the magnetic charges are produced on a belt rather than on a sensitive paper. So magnetic printers are much slower than the electrostatic printers, up to 200 lines per minute, but do not require a special paper. Then we have the page printers. Page printers are an impact, very high quality speed printers capable of printing a page at a time. They can be electrostatic, xerographic laser, then electrostatic page printers. Is a printer that uses charges. So this one is a printer that uses charges. The characters are created using tiny dots, 200 to the inch, giving a high quality, which does not look like matrix printing. So the document outline is coded and stored for printing with the data when ready. Letterheads and logos can be created electrostatically using chargeable metal cylinders. Pre-printed stationery can also be handled. So, xerographic printer, it's a printer that has an inbuilt processing power of production of multiple copies is possible. These are an adoption of the xerographic office copier. Xerographic is the process of an electronic printing or dry photocopy photography in which negatively charged powder is sprinkled on a positively charged surface. Xerographic printer produces a sharp character image on letter-sized paper. So the printer usually has an inbuilt microcomputer and can produce and collect multiple copies. It operates at about 400 RPM per minute. So that is reams per minute. Then we have the laser. These are probably most advanced computers and use laser beam to produce characters on the surface of a rotating drum. A toner that adheres to the images is then transferred to the paper. Some laser printers are running at speed equivalent to 2100 lines per minute, so that they are needed only in large volume applications, e.g. mailing, short pricing lists in many companies. Then we have a plotter, which we also call or we call it graphic plotter. Is a device for producing graphical output on paper. It consists of digital computer outputs into illustrations such as graphs, bar charts, pie charts, maps, or technical drawing. So a digital plotter works by converting digital coordinates, rather like map reference, into pen movements. Alternatively, an incremental plotter sends signals to tell the pen how far to join from its present position. So normally these are used for in survey, in maps, architectural design. You can use them. Plotters are very important. They can use them to draw. So plotters are not always directly connected to the computer because pen output is fairly slow. That's wasting time. Rather, a program magnetic tape. The tape can then be run later by a small processor, which will control the specialized plotter system. So there are two types of plotters. We have the flatbed plotter. This is a fixed flat table or bed on which the written pen can move over the paper, up to move without drawing, down to draw, and in the north, south, west, or east directions. A drum plotter. Here, a roll paper mounted on a drum can be moved back and forth the paper moves around the pen moves around across the paper. A combination of drum and pen movement allows a line 3 to be drawn anywhere on the paper. So having looked at the plotters that give output in hard copy, let us now look at the output devices that give outputs on or output a soft copy. So soft copy, like the monitor, what you see on the screen, monitors, computer can have a visual display unit, are the main output devices of a computer. It forms images from tiny dots called the pixels that are arranged in a rectangle form. The sharpness of the image depends upon the number of pixels. It is similar to a TV screen, either monogram with black and white or color, and it displays the output. It refers to as the video visual display unit. Several types of monitors are in use. Some of them are color graphic adapter, enhanced graphic adapter, video graphic adapters, super video graphics adapter. So the screen sizes differ from system to system, and the standard size is 24 lines by 8 characters. Most systems that have provisions for scrolling, which helps in moving the text vertically or horizontally on the screen. So the monitor is mainly the cathode ray tubes. We have the flat panel tubes. We have the TFTs, which are called the thin film transistor or plasma screens. Then we have the light emitting diode. So these are just the types of, but CRT is the most common cathode ray tube. I think for those who have done physics, you have seen this type of screen. So we're just not going to, but we're saying it's a cathode ray tube. So this one, I'm not going to dwell on it because most of you have seen this. Now this one, the next one is the flat panel display monitor. The flat panel display refers to a class of video device that have reduced volume, weight, and power requirement in comparison to the CRT or cathode ray tube. You can also hang them on walls or wear them on your wrists. Current uses of flat panel display include calculators, video games, monitor, laptop computers, graphic displays, and even watches, smart watches. So the flat panel display is in two categories. We have the emissive devices. The emissive discharge are devices that convert electrical energy into light. Example is plasma panel and the LED light emitting diode. Then we have non-emissive displays. Non-emissive displays use optical effects to convert sunlight or light from one other source into graphic pattern. For example, we have the liquid LCDs, liquid crystal devices that are used. So these are the screens you're talking about. So this activity now, I think it will be also, the activities are online, so make sure you also do the activities. But now distinguish between the following devices: LCD and CRT, ALU and control unit, and then keyboard and scanner. Can you distinguish them? Then hard copy. That one you can do it on your own. So having looked at the output devices, it's important to have some form of storage for the data and programs, either temporarily when the program is running or long term to preserve the programs and data using back storage. So a computer can function with only processing, memory, input, and output devices. However, to be really useful, a computer also needs a place to keep program files and related data when they are not in use. The purpose of storage device is to hold data permanently, even when the computer is turned off. So there are three major distinctions between storage and memory. There is more room in storage than in memory, just as there is more room in a file cabinet than there is on top of a table. So contents are retained in storage when the computer is turned off, whereas programs or the data in memory disappears when you shut down the computer. So storage devices operate much slower than the memory chips, but storage is cheaper than memory. So we are saying that storage is cheaper than memory because memory is a bit expensive. So we'll now look at the types. There are two main types of computer storage. We have the magnetic and optical. They are covered in the following section. So the backing storage, although backup, so it's more backing storage. When you say backup, backing storage. So although a computer could contain all business information in the internal memory, it will be rather impractical to do as much. Manuel Odhiambo, what's your question? Raise your hand. What is it? Manuel Odhiambo. Sit and what? Emmanuel Odhiambo, you raised your hand. Can you have a comment? What's the problem with you? Comment on the chat so that I can see. If you can't try, you can't talk. Manuel Odhiambo. Manuel Odhiambo. I'm not fast. I'm just moving slowly. I thought I'm even going with a slow speed, and you're saying I'm moving fast. So let's continue because I've not gotten what Emmanuel is saying. So, although a computer could retain all forms of information in its internal memory, it will be rather impractical to do so, and it will require millions of bytes of storage capacity, such as semiconductor memory in the form of RAMs, that is random access memory. It is usual to provide the computer system with offline storage, referred to as auxiliary or secondary storage. So for the storage of master files and programs related to specific application, until they are required and transferred into internal memory. So backing storage is also used for storing data to the computers when power is interrupted. So what we are saying in backing storage, you can either store on a CD, on a flash disk, you can store on a hard disk, any form of memory that you can carry your data online. You can also put it in magnetic tapes. I know some of you have not seen magnetic tapes, but during our time, we used to have compact discs. Unasikia muziki kwa compact, but now those are also storage devices. They use even to store music. So those are the kind of memory, the magnetic tapes and what. They are just external. You can store them externally, and tomorrow you access the same information. But anything in a RAM normally is volatile. So what happens that you need to have the back storage so that tomorrow you can access the information that you have. These days you can also store them on. These days you get issues to do with Google Drive. You can store. It's also a good backing storage where you store it online, and it's not just stored in the air. This idea that computers store things in the air does not exist. Even in Google, what you access, it's actually stored on some storage device. There are acres and acres of there are acres and acres of flash disks. So computers generally employ magnetic storage of one type or another, but new developments are taking place, such as optical disk, which record data by means of laser. So the advantages of back storage: it is cheaper to store in secondary devices like magnetic media than in a filing cabinet or in main memory. There is more capacity in secondary storage than in primary storage. That is it. Then data stored in a secondary storage is safer than tampering by unauthorized people or from hazards. They facilitate each movement of data stored electronically. For the types of backing storage, there are many media for backing storage. The main devices and media are magnetic tape unit, magnetic tape, magnetic disk unit, magnetic disk. We have then the magnetic diskette unit, which is the magnetic floppy disk. Then you have the optical disk unit, which is the optical disk solid state storage devices. Then you have the mass storage devices and media. So we are looking at now what we call the magnetic tape. These were the first kind of storage, secondary storage. This is mainly a flexible plastic ribbon on which data can be stored using a magnetic process. It has some peculiar characteristics. So physical characteristics, plastic base coated with, no, so there are physical characteristics, plastic base coated with the metal oxide film, data recorded as the magnetized spots, each one representing a binary digit. Standard width is 1.72 centimeters. Though size varies from 0.86 and 2.54. High capacity, standard reel 720 m in length, but again sizes vary. Then recording of the tape, data are recorded in binary coded decimal format. That is the most common form of coding. These ones we are going to deal with the BCD. We are going to deal with it towards the end of this particular course. Then we have the 7-track ASCII, which we'll talk about. Then we have the American Standard Code for Information Interchange, which consists of a 7-bit character plus a parent. This one we are going to talk towards the end. So the rate of reading, the rate at which data can be read from a tape is called the transfer rate, which depends on the recording density and the tape speed. For example, a tape with 160 BPM density and a speed of 120 centimeters per second has a transfer rate of 160 by 125, which is equivalent to 200 bytes. 200 bytes per second. So if you convert it into kilobytes, you divide by 1024. That will be around less than 200. But if you divide by 1024, you can get in terms of kilobytes, you get in terms of megabytes, so you can do the conversion. So this is known as the instantaneous transfer rate. The actual average transfer rate will be less because of the inter-block gaps. So advantages of magnetic tapes, the speed, the transfer rate, 50,000 to 100,000 or more characters per second is quite adequate for many applications. Capacity, a standard reel can hold 10 million or more characters depending on the blocking factor. Thus, tapes can be used for large film files or for dumping from disk files. Then the cost, magnetic tape is the cheapest magnetic media. Convenience, it is light, compact, and easy to store in racks. Some organizations have thousands of reels in storage, libraries, or banks. So disadvantages of magnetic tapes. Tape is a serial media, and therefore searching is necessary. This makes it impractical for direct access applications. A record on magnetic tape cannot be updated in play or in situ. Records to be updated have to be read, updated, and then written to a tape. This does not have, just a minute. So a record on magnetic tape cannot be updated in place in situ. Records to be updated have to be read, updated, and then written to a second tape. This does not have safety benefits. However, in that origin is preserved. So there's also what we call the father-son principle. But magnetic tapes, I know some of you have not seen, It's good I show you what one. Let me see. Mark, can you have an image of magnetic tape? Just look for one, a magnetic tape, a compact disc.
Let me share.
Just look for an image.
Okay.
Then you will display. So the uses of magnetic tape offline storage of large files. Tapes can be convenient kept in storage tracks. And are loaded onto the tape drives and processed as they are needed. Backup storage for offline disk files to prevent loss of data. Disk files can be periodically dumped on the tape. Medium for key to tape data entry, now largely superseded by key to disk. So magnetic disk. Looking at magnetic disk, it's a flat circular platter on which data can be stored. Magnetic disk is the most common used form of back storage, although other media, optical disks, may become one cost-effective for some application. However, magnetic disks themselves continue to be improved in terms of cost and performance. So disks are excellent for large data files and databases at a reasonable cost. So the characteristics include, so it's important to know the characteristics. A disk pack is made up of a stack of rotating metal disks, 6 or more mounted on a spindle. Several disks can be stacked on a spindle and enclosed in a unit called a disk pack. Each disk is a thin metal rigid platter, similar in size and concept to an LP, connected on both sides of the magnetic material. Then data are recorded on surfaces in the form of magnetized spots. The presence or absence of a spot denotes binary 1 or 0. So, in terms of storage, digital concept is that in the storage it's either 1 or 0. I think we are going to do it in the last bit. So 1 means there's a presence, then absence is 0. And normally that is stored in terms of zeros and ones, and we have also the different standards that we're going to look at towards the end of this particular course. So the surface of the disk is divided into tracks, which is in turn divided into sectors. So the recording density is greater towards the middle of the disk, so that all tracks contain the same amount of data. So the disk pack can be loaded into a disk drive for reading and writing. The capacity of a disk pack is of the order of several hundred gigabytes reading and writing to the disk. So this one you can also look at it, and it's a very important concept. This last part you can finish. Then we have the other thing I also want to talk about, which is the disk capacity. Disk capacity depends on the number of recording surfaces, the number of cylinders, the recording density, bytes per track. This is in terms bytes is data, of course, and I've shown you how you can do the conversion from bytes. You go to kilobytes, megabytes, gigabytes into terabytes. So tracks per cylinder could be like 24, then cylinders per pack 1,000, giving a total of about 209 GB. So what are the advantages? Data can be accessed directly. There is no need to search through other records. Sequential processing is needed. Very high capacity at low cost. So that's per character stored. Disk packs are convenient to handle and store. Currently, the most popular storage method in businesses. Then we have this. What are the disadvantages of these particular disks? Disk drives and disks are more expensive than the tape drives and tapes, respectively. Slower than newer forms of storage, e.g. magnetic bubble, can be unreliable, susceptible to dust, static electricity, head crashes, uses most business situations, particularly useful in online inquiry response systems where direct access is essential, reservation, and booking systems. Then we have the magnetic disks, the floppy disks. Don't get confused. This is a type of magnetic tape. Floppy is a single flexible disk held in a protective jacket. It's made of polyester film coated with metal oxide. These floppy disks Again, I think it looks like that. These are very old. I think they are outdated right now, but this is what we used to use in our days, in our heydays as we were doing computer science. These were actually the tapes we normally used when we were doing any form of storage. We are using these forms of storage devices. So that is very key. All the other storage devices we have been discussing were using magnetic technology. Now we focus on devices that use light. So these are what we use the light, that use light. And in recent years, optical devices or compact discs, the CDs, have become very popular. And they also, right now, people have moved to flash disk and the memory cards away from this. So this now, actually the most popular right now is memory card. People now have memory cards and people also have flash disks, which are more common, but this has also been overtaken because it's very tricky. We get a small scratch, you lose the data. So these are made up of thin metal film, polymer compound onto which a lesser bands digital information in the form of microscope pits. They are read by another laser, which converts the pattern of bits into a digital message. The storage capacity is vast up to 1 gigabytes. 1 gigabyte, i.e., 1 billion character has been quoted. Tracks on the optical disc can be packed very closely together. The latter is known as a compact disc, read-only memory. That's a CD-ROM. And a typical storage capacity is 700 MB, 700 MB of user data. So they are massive storage. They have massive storage capacity. That's one of the advantages. They have high quality pictures, and sound can be achieved without noticeable deterioration, even after continuous use. Information can be retrieved quickly and randomly. They are reliable. They have long lifespan than magnetic disk. No mechanical contact between disks and the optical system. Disks are coated against and scratches, then exchangeable. The disks themselves are fairly expensive, but are relatively cheap in terms of cost per character stored. Hard to copy, sometimes because of copyright reasons, but you can still copy them. Then the disadvantage, I think there's an advantage. Useful. Then we are saying next is disadvantages: costly hardware for reading, expensive to produce master disk, little software, often of poor quality, later development of standardized size and formats, but CD-ROMs have an agreed standard. Then temporary read and write, read and record only. It is all still a problem to write to a disk, even harder in erasing and recording. So for this, an optical disk will not be replacing existing storage media just yet. So the next step, making optical disk read and writable, is still but right now, it was experimental, but right now it has been done. So these have much more higher recording density than conventional magnetic disks. So these have two variations. So it's good to know that these have two. So we have what we call the CD rewritable. It's a CD that you can rewrite. You can write on, then use. Then when you want to write, you can also add on information and rewrite. So when I talk a CD rewrite, then we have what we call this one. The data written on them can be overwritten or reversed. Then you have CD recordable / read one. Write once and read many. It holds data that is permanent, no overwriting. They hold data that is not likely to exchange in future. Once data is written onto the surface, the worm disk, it cannot be changed. So the digital versatile disk, the DVD, is another. DVDs also another storage device. DVD stands for digital versatile disk. It is similar to a CD-ROM, except that it can store large amounts of data. The storage capacity of a DVD is at least 4.7 GB. So DVDs can store up to 17 GBs and are also available. Because of their capacity, DVDs are generally used to store a very large multimedia presentation and movies that combine high quality sounds and graphics. So DVDs, actually, we have also been having the DVDs, which have really helped in storage of data. But because they have high capacity, you can store movies. I think we are also now moving from this point. Then we have the solid state devices. Other forms of storage have developed, which are called the solid state. No moving parts. So the comparative slowness of current disks and tapes is caused by the physical movement of recording surface and with the disks of the heads. So there is no physical movement in the solid state devices. These devices are another category of semiconductor memory, but given somewhat slow access speeds to the data than RAM and ROM, and are therefore not suitable for main storage. The two common types of solid state storage devices used for backing storage are magnetic bubble memory, that is the charge coupled device. Then you have the flash memory and you have the magnetic bubble memory. The flash memory, flash disks, yeah, in the bubble memories, data is stored as a tiny magnetic domains, the bubbles, which continually circulate past read-write heads. Some materials in natural form are magnetized, and application of bias field results into magnetic bubbles. So this presence of a bubble can represent a bit. Application of drive field, a bubble generator, a bubble detector, and bubble annihilator constitute the bubble memory. So we have the CCDs, the chargeable coupled devices. This produced by a form of MOS technology. This is produced by the MOS technology. They are relatively fast compared with bubble memory, but are volatile, whereas bubble memory is not. In the current state of development, solid state of development, solid state storage is halfway between established memory systems and back storage. It provides access to data that is faster than conventional back storage devices, but slower than memory. On the other hand, it has a capacity higher than memory, but lower than back storage. So the disk technology continues to improve at such a place that a solid state device have not yet made a breakthrough. So we have the flash drive. It is a small portable device that can be used to store, access, and transfer data. Due to its small size, it's commonly called the pen drive. It is also called USB drive. We can read, write, copy, delete, and move data from computer to open drive or pen drive to computer. It comes in various sizes, 2 GB, 4 GB, 8 GB. Right now we have even terabytes, 10 terabytes. So it's something that is there and it's very good. It is most popular because it is easy to use, small enough to be carried in a pocket. This device is plugged into the USB port of the computer, and the computer automatically detects the device. I think we have also the memory, the memory cards are also small devices that can be put in a phone and a memory card reader, and they can be able to read all the data and storage. And I know most of you, when your memory is depleted in the phone, you normally add a memory card. So memory cards are very important when you add them to your phones because it expands your storage. The mass storage devices and media. So it's good to note that because memory cards are not here, I'm just saying it's important to note that is also a storage device. The mass storage devices and media. Some large corporations and government agencies have a need for vast data storage capacities. This need can be met by mass storage devices. These devices are automated libraries of a disk and a tape cartridge, rather like jukeboxes. So the total capacity of such systems tend to be expressed in terms of gigabytes or thousands of bytes. So in summary, in this topic, you have learned the computer system, what a computer system is. In defining the computer system, we had a look at the 4 parts. We also followed this up by looking at the computer hardware and classifying the various parts in details. So in topic 3, we will discuss the computer software, that is procedures or programs that enable the user to use the computer hardware. We will also look at how the various groups of computers software work to help the user work well on their tasks on the computer. But before you go to this to topic 3, let us see how well you have understood this topic. So there are questions here. I think they are also online. You try to answer them. So can you try to answer these questions in the next few minutes? So I'll just put the chat box on the sides so that you can respond to these questions. So let me move the chat bot here. The chat. So can you type in so that we can see what you're saying? Let me move it to this side. But before that, Mark D, you got an image of a compact disc tape. Mark D.
Yes, I did.
Yeah, I can share. Then okay, can you share your screen?
Yeah, here they are. We have the magnetic tape. We used to call them compact. When we are playing some music some time ago where we want to arrive to a particular music, you'll be forced to rotate this magnetic tape with a biro pen. For those who used to have cages or silvers. So I think data was accessed sequentially, where one needs to strong or maybe to roll this magnetic tape from one song to another. For those who have been with the older brothers, they can attest that this was one of the best music 2000 years, 2000 or 1990s. If you were to listen to Rose Mohando, Marumbini, yeah. Then we have magnetic disc, or we call it, I don't know, disco. Yeah, where those old grandpas used to have this magnetic disc that was black in the color, placed on the disco. I don't know which the best language I can use. So that this head they should have they move this head from one track to another. Select a
Ilikuwa inaitwanga
particular.
sahani. Zamani
Yes,
walikuwa wanaitanga
sahani.
sahani.
Okay. Okay.
Very
Then,
old.
then we have the optical disc. So this one, as the name suggests, the songs are read. They are read by use of magnetism. So this tape is induced by magnetism, where the current, when the reader moves on this tape, it will be generate current, and that current is now translated into a music. The same as this also happens the same. Then you have optical, as the name suggests, use optics. That's light. That is why it's shiny. So when the light rays on the reader on the disc player shines on these tracks and sectors, is translated into current, which now forms music. That's what maybe you can share on that. Someone's asking what is the Marumbini song. Okay, for those old guys, you understand what I mean by Marumbini. So these were the best, those old 1990s. when
Wakina
some
Ibon
of you,
Chaka Chaka.
yes, Ibon Chaka Chaka,
Yeah.
yes,
Those are the guys who used to rule.
yes,
Kanda Bongo man.
yes. Yeah, that is it. You can continue, sir. You can pick from there.
Just share the assignments that are online for that week, for the last 2 weeks. I think on my side, I'm not able. Let me just share from your side. On computer hardware.
Allow me maybe to check on them, to download them so that I can share.
Share. Can I share from my side? I can share.
Yes. Just continue. Just continue.
So we have been doing week, we had the first part, week 2, which was more of, I told you we are going to go through 6 topics. So we have finished, we finished the introduction to computers. You will get that it was quite long. We talked about this. Now we are looking at the hardware. This is what we have been doing. So it's important that you look at these resources. And then maybe we just unhide this. Magdi, you can just enable the assessment.
There's one just below week 3. Just scroll.
Up.
Just continue.
Then we have also the discussion forums. You click and you discuss what is there, the discussion forums. Magdi, I think we need to update that. Maybe that is the only thing for them.
There's one on topic 3. I think the topic 3. Let me just check from my side. Okay, there's let me just share. Yeah, I think under topic 3, under basic computer.
Actually, under topic what? 3? So actually go to your, what you are saying is go to your, because it's important for you to know that there are also assignments. So for computer hardware, there are whole instructions, there are videos you can listen to. If you come here, you can see there's a lot of notes. So if there are instructions on how you will read this week 2. And this week 2 has been very long because imekuwa na vitu mingi. We have almost done it in 3 weeks because, but it's topic 2. It will not even be week 2, it will just be topic 2. That it has all the weeks up to tumefika paka topic what? Actually, Mark, you have done topic 3. Today we have done up to 3. So we have done topic 2 and topic 3. At topic 3 tumeongea juu ya output devices and what. And at the end of it we have a quiz. So you look at the quiz and it's compulsory and be able to answer. So this quiz is compulsory. Make sure that you do it in topic 3. And also the other ones, I think we had some questions in the other topic 2. Make sure that you also have to do them. So the end of quiz, and you can see the questions are already here. So ensure that you answer, they are compulsory. Some of the, oh, now you are seeing from my side. I'm not seeing as a student, but the questions are here. So you will be able to access and be able to do them at your own time. So next time we are moving to topic, 4, then 5. After 5, we only have 2 times, then we do a cut, then we finish the rest. Tukona kazi, but we are going to finish. So having said that, I think for today, do the quizzes online for topic 2 and 3, you finish. Then we move on next to topic 4 and the rest. Thank you very much. God bless you. Enjoy your week and finish your assignments. If you don't finish, don't complain. Just do what you're supposed to do. Bye. Mark, do you have anything? Mark, do you have anything?
That's just what I wanted to tell them, that the quiz will be open. Yes.
The quiz is open.
Hopefully you're getting me. No, I don't have anything. Just to advise students to do that quiz. Yes. and that quiz will add to their final mark. So if they don't do that quiz, it means that they will be at risk of failing the course. So they should do that quiz. I'm in the office to assist them in case of any challenge.
Tell them to note the deadlines. I can see the deadlines there. It's Monday, 7, 10 a.m. and it closes on Wednesday, 9, 11. Sasa wewe usipofanya unakaa unang'edhie. Kindly find time, do it, and the time is there. Second years and first years, make sure you are doing it for education, especially for education students. Those doing a bachelor's degree in education, second year, make sure you are there. Then all the first years who are supposed to do this course, ensure that you also do that. So having said that, I think we are through. Bye. Bye, everybody. Have a nice week, guys. Finish the assignments on time. The remaining 1 hour, you can use it for the assignments. For Irene. Till next week, Monday. Bye. Bye-bye. Bye.